Hello friends, I am Ameer. Today we are discussing about addressing modes in 8086 microprocessor. The 8086 microprocessor is a powerful and versatile chip at the heart of early personal computers. Introduced a range of addressing modes that allowed to efficient and flexible memory access. These addressing modes are fundamental concepts that enable the microprocessor to interact with and manipulate data stored in memory, forming the foundation for complex program execution and data processing. The 8086 microprocessor offers a diverse set of tools for developers to optimize their code and unlock the full potential of the system. The fundamental addressing modes in the 8086 microprocessor is direct addressing, where the memory location is directly specified in the instruction. This means that the exact address of the data or instruction to be succeed is provided as part of the opcode. This addressing mode is efficient for accessing fixed memory locations as the processor can quickly retrieve the data without the need for additional calculation for direct indirection. Is very simplicity and speed, also limited flexibility. Next one is indirect addressing. In the 8086 microprocessor, indirect addressing is a powerful addressing mode that allows for more flexible and dynamic memory access, unlike direct addressing, which uses a constant memory location. Direct addressing uses the constant of a register to determine the memory location to access. This is accomplished by storing the memory address in the dedicated register, such as BX, BP, SL or TI. Overall, indirect addressing is a crucial addressing mode in the 8086 microprocessor that provides programmers with increased flexibility and power in managing and accessing memory. Its dynamic nature is a key feature that distinguishes it from the more static direct addressing mode. Third type addressing mode is immediate addressing. It direct access data and compact code, and limitations and consideration is while immediate addressing provides direct access to data and compact code, it was same limitation. The size of the immediate operand is limited to the size of the instruction format, which can be 8-bit or 16-bit. Additionally, the immediate value must be a constant, so it cannot be used to access. Next addressing mode is register addressing. Register addressing is a fundamental addressing mode in the 8086 microprocessor. In this mode, the operand is directly specified by one of the processor's internal registers, such as the general purpose registers. This addressing mode is efficient and fast, as the processor can directly access the data stored in the registers without the need for additional memory access. This addressing mode is register indirect addressing. It's accessing memory via register. Register indirect addressing is a mode where the memory address is stored in a register rather than being specified directly in the instruction. This allows for more flexible in accessing memory, as the address can be dynamically calculated or retrieved from the variable location. The content of the register are used as the memory address to read from or write. The next addressing mode is relative addressing. Relative addressing is a fundamental addressing mode in the advantage of relative addressing is that it provides a more efficient way to access memory compared to absolute addressing, which required the full memory address to be specified. Relative addressing allows the CPU to reach a wider range of memory locations using a smaller instruction size, as the displacement value is typically much smaller than the small address. Next is indexed addressing. Indexed addressing is the memory addressing mode used in the 8086 microprocessor. In this mode, the effective address is calculated by adding the content of a base register to the content of the index register. This allows the processor to access memory locations relative to the base address, with the index register used to offset the address. Next is base pointer addressing. It typically three types: base pointer, index register, displacement. Base pointer addressing is a powerful addressing mode in the 8086 microprocessors that combines the use of a base pointer register, an index register, and an optional displacement value. This addressing mode is particularly useful for accessing data structures stored in the memory, such as arrays, linked lists, and other complex data types. Now the last addressing mode is base index addressing. Here, combination registers based index addressing combines the content of the base registers, and indirect memory accesses in the base index addressing the memory location is not directly specified in the instruction. And next one is versatility and optimization in base index addressing. The base index addressing mode is a powerful tool in the 8086 microprocessor, as it allows for efficient and optimized memory access. Programmers can leverage this mode to create compact and efficient codes, especially when working with data structures or arrays. An example of usage of base index addressing. A common example of base index addressing in the 8086 microprocessor is when accessing elements in a two-dimensional array. The base registers can hold the starting address of the array, and the index registers can hold the row index. By adding the contents of bx and si, the efficient address of the desired elements can be calculated and accessed efficiently.